aerodynamics treats of the motion of air or other gases and of the forces acting on solids in motion relative to such air or other gases. Relative wind is the motion of the air with reference to a body. It may be the result of moving air and a stationary body, or still air and a moving body, or both air and body may be moving with reference to the earth. In this case, the relative wind is the algebraic sum of the two motions. An air stream flowing past a flat plate exerts upon it force whose direction depends upon the angle between the plane of the plate and the direction of airflow. This force may be analyzed into component forces, which are called lift and drag. Lift acts at right angles to the relative wind, and drag acts parallel to the relative wind. If the plate is held in a horizontal airstream in this manner, lift is opposed by the weight of the plate, and drag is opposed by the tension on the cord. The acute angle between the relative wind and the face of the plate is called the angle of attack. This angle may have any value from 0 to 90 degrees. It may be either positive or negative. An airfoil is any surface designed to be projected through the air in order to produce a useful dynamic reaction. Airfoils which have been studied and used vary widely in form. This is probably the most common type of airfoil section. Others are convex on their upper surface and concave on the lower, while still others are convex on both surfaces. Relative thickness and curvature of airfoils vary considerably. In general, a line through an airfoil's leading and trailing edges is known as its chord. This is the case with an airfoil having a symmetrical double convex camber. In an airfoil which is convex on its upper surface and concave below, the chord corresponds to the arc of the medium camber. In other airfoils, it is the line of a straight edge brought into contact with the lower surface at 2 points. The acute angle between the chord of an airfoil and the relative wind is known as the angle of attack of the airfoil. A wind tunnel is a device for testing reactions on airfoils and other aerodynamic shapes. It usually consists of a large tube with a constricted throat. A propeller produces airflow, and a honeycomb arrangement is placed at one end to ensure straight airflow. When lift and drag of an airfoil are to be measured, the model is placed in the chamber and supported by wires. One wire runs from the model through the top of the tunnel to a balance arm which is weighted so as to maintain tension and compensate for other forces. From the leading edge of each wing, a wire runs forward in the direction of flight over pulleys, and down to a bar on a platform type of scale. A second pair of wires runs vertically downward from the wings to another scale. Finally, a wire extends from the tail down to a third scale. In this way, the model is suspended so that the various forces exerted upon it may be measured. The position of the model is observed through sighting scopes. With the air flowing at the desired velocity, drag force is exerted upon these wires. Front lift is measured as the actual lifting force upon these wires. Rear lift as the force upon this wire. Total lift is the sum of front and rear lift. Here is one of the Army's wind tunnels at Wright Field. It is nearly 100 feet in overall length, and the test section is 5 feet in diameter. On the intake end, a huge honeycomb arrangement of metal vanes straightens the airflow. Four electric motors of 400 horsepower each furnish power to turn the fan. Two of the motors are shown here. There are two others inside the tunnel. The fans are 12 feet in diameter and have 12 blades. When driven at a speed of 700 RPM, they produce an airspeed of approximately 200 miles an hour in the tunnel. Wind tunnel tests show how lift and drag vary with the angle of attack of an airfoil. In general, as the angle of attack increases,